This is the IE 441 Capstone project at Iowa State University, and we are Team 14 with our project taking place in spring 2021. Team 14 is comprised of Hunter Barnhart, Jared Bunn, Ethan Jacoby, and Kevin Nigg. The project was set at a meat packaging company in Iowa. The team's main focus was on the FlexPack production line in the large ready-to-eat room, focusing on ham bagging. The production on the FlexPack production line is not reaching its full potential output, which is leading to a longer day for production. The provided project deliverables that are used in this project were the air bagging table implementation, time study to determine efficiency, work sampling to determine productivity and idleness, and a material flow analysis. The three objectives for this project is to increase the FlexPack production line efficiency from the bagging process to the labeling area by 10%, reducing idle time for the employee to place the bagged hams on the sealing platform from the conveyor belts by 10%, and testing and trial of using the air bagging table in the FlexPack production line.
Investigation and implementation of the air bagging table was noted as a key objective for this project. Investigation into the air bagging table occurred in the CSA phase where the team looked at the machine process as a whole. The team member noted that an existing pin limited the movement of the guide arms, causing an inflation issue where the bag would get caught underneath the arm. A new pin location was recommended and then implemented, which allowed for proper inflation of the bag. The amplifier and inflator was then tuned for a strong initial burst of air to split the bag and then a steady flow of air to keep the bag inflated. Bag replenishment was determined to be a quick process as the machine uses bags on ribbons of 1,000 or more. Implementation of the air bagging table was successful. Employees were trained on site to operate the air bagging table, and initial results show an immediate 12% reduction in bagging time.
Time studies in this project involved observing the bagging area at the beginning of the production line to determine average bagging times and fluctuations in work in progress to identify options to increase efficiency and output. The CSA data collection oversaw the manual bagging process currently used on the production floor to create a baseline to compare against the future state. The FSD data collection replaced the manual bagging process with the implemented air bagging table and found of 2 employees operating the new machine, bagging times decreased by 12% compared to 1 employee bagging hams individually. Additionally, a learning curve was observed during the FSD indicating with further use of the machine, the efficiency gains might be larger than 12%.
The team conducted a material flow analysis in the CSA to better understand how the flow of products, people, and machines work together. In the FSD, the team added the air bagging table in parallel to the manual bagging process on the updated material flow analysis shown on screen.
Work sampling was performed to observe the proportion of time the conveyor carousel employee at the station after the bagging area was idle or working. CSA data results indicated that idle times were lower than the team's initial assumptions. Further, the CSA data results showed that for any improvements to occur for this position, these improvements would need to occur in the bagging area as these two stations are directly linked. Due to time of production constraints, a work sampling study was unable to be performed in the FSD.
The ROI for the air bagging table for the October through December season is around $12,000 saved per relocated worker per season, and for the year it is around $57,000 per relocated worker per year. The ROI for the carousel speed improvements for the October through December season is around $5,000 per season, and for the year it is around $22,000 per year. There are 4 main qualitative impacts. The first is a 12% efficiency gain in bagging speed. The second, the air bagging table was implemented into the production line. Third, the objectives of implementing that air bagging table and the efficiency gains was met. Finally, the deliverables were completed. We would like to thank the company and the university for their help and opportunity in this project.